From the molecular formula, we calculate that the molecule contains 5 unsaturations. Five signals are present in the NMR spectrum, indicating 5 sets of equivalent hydrogens in the molecule. The integral values for the 4 signals in the spectrum are 0.95, 2.1, 2.13, 2.2, and 3.26. Adjusted to whole integers, the integral values are 1, 2, 2, 2, and 3, and the overall integral value is 10. Since there are 10 hydrogens in the molecule, one adjusted integral unit equals 1 hydrogen. Signal 1 has a chemical shift of 9.86 parts per million, which falls into the region for aldehyde protons. Signal 2 has a chemical shift of 7.81 parts per million, which falls into the region of aromatic hydrogens, ortho or para to an electron withdrawing substituent. Signal 3 has a chemical shift of 6.97 parts per million, which falls into the region of aromatic hydrogens, ortho or para to an electron donating substituent. Signal 4 has a chemical shift of 4.1 parts per million, which falls into the region of aliphatic hydrogens with a strong electron withdrawing substituent. Signal 5 has a chemical shift of 1.44 parts per million, which falls into the region of unsubstituted aliphatic protons. Signal 1 is a singlet, which means that it is not coupled to any other hydrogens. Signal 2 is a doublet with a J value of 8.8 Hz, which means that it is coupled to one other hydrogen. Some additional features are present due to second-order splitting. Signal 3 is also a doublet with the same coupling constant as Signal 2. Signal 4 is a quartet with a J value of 7.0 Hz, which means that it is coupled to 3 hydrogens. Signal 5 is a triplet, which means that it is coupled to 2 hydrogens. It has the same coupling constant as Signal 4. Signal 1 represents an aldehyde hydrogen not coupled to any other hydrogens. Signals 2 and 3, 2 doublets coupled to each other, represent a para-disubstituted aromatic system. Signals 4 and 5, a quartet and a triplet coupled to each other, represent an ethyl group. This accounts for all the carbons and hydrogens, as well as 1 oxygen, and all the unsaturations. The remainder is 1 oxygen. From the chemical shift of signal 4, we know that the ethyl substituent is a strongly electron-withdrawing substituent, such as oxygen. From the chemical shift of signal 3, we know that the hydrogens indicated by signal 3 are ortho or para to a pi-donating substituent, such as oxygen. From the chemical shift of signal 2, we know that the hydrogens indicated by signal 2 are ortho or para to a pi-withdrawing substituent, such as a carbonyl group. The compound is p-ethoxybenzaldehyde.